Hey everyone, we're going to take another look at writing equations for lines, and this time we're specifically going to look at it with the lens of writing an equation for a line that's parallel to another line. And this follows the inquiry activity that you guys just did, and also the screencast video that I made showing how parallel lines have the same slope on Desmos. So if you haven't watched those ones yet, make sure that you watch them. Or if you haven't done that activity and watched that one yet, make sure that you do that. And so we're going to jump right in and write some equations for lines here. All right, let's start out by looking at this question. Write an equation for a line that's parallel to the line y equals 2x plus 3 and has a y-intercept of -2. So I know that to be able to write an equation of a line, I need to be able to do this in slope-intercept form, which is just y equals mx plus b, where we know that m is the slope, and we know that b is the y-intercept. Now to write our line, we know that we need a slope, and we know that we need a y-intercept. And then we know that we leave x and y just as x and y, unless we don't have a slope and a y-intercept, but we do have a coordinate. We only need this part, but if we don't have both of those, then we need to jump down and do something with our x and our y. So let's look and see if we have what information we have from this. It says write an equation for a line that is parallel to the line y equals 2x plus 3 and has a y-intercept of -2. Well, right off the bat here, it tells me that I have a y-intercept of -2. So I can put that right in here. There's part of my information done. Now we also need a slope. It doesn't give us a slope, but it does say this key information that our line is parallel to the line y equals 2x plus 3. And if you think back to what you learned in our inquiry activity, or what you learned from the screencast that we watched, we know that parallel lines have the same slope. So if our line is parallel to this line, we know that we can just steal its slope of 2. So I'm going to put a slope of 2 and a y-intercept of -2, and now I can just write the equation for my line because I have a slope and a y-intercept. So our line would be y equals mx. M is 2, our slope is 2, x, and then our y-intercept is -2, so I'm going to write -2 instead of b, and there's the equation for our line. It's that easy. Let's take a look at one that's a little bit more difficult than this. Alright, so let's try this one right here. Write an equation of a line that passes through the point -2, 1 and is parallel to y equals 5 minus 3x. So again, we always know that we're looking to write our equation in the form y equals mx plus b. We know that we need to find a slope to do this, and we need to find a y-intercept to do this. And that's all we need if we have those. Otherwise, if we don't have both of those, we need an x and a y, and we can use those to find the missing piece. So let's look here. Do we have a slope or a y-intercept? Well, write an equation of a line that passes through the point -2, 1, and it's parallel to y equals 5 minus 3x. Well, if we know that it's parallel, we know that it's going to have the same slope as this line. Now, what you'll notice here is this line, y equals 5 minus 3x, is not written specifically in slope-intercept form. We just need to rearrange it the tiniest bit. So let's take that line, y equals 5 minus 3x, and we want to get it into y equals mx plus b. Right now it appears like it's y equals b plus mx. So we need to rearrange this. This part here, -3x, needs to come first. So y equals -3x. And then this 5 right here is positive, so we'll write plus 5. So we've rewritten this equation this isn't the equation of our line, this is the equation of the line that it's parallel to, we can see that the line it's parallel to has a slope of -3, so we know that our line will also have that same slope since they're parallel. Now, we don't have a y-intercept here. Obviously, the line that it's parallel to has a y-intercept of 5, but that doesn't help us because this line is just parallel to that line. It doesn't necessarily go through the same, through the y-axis at the same spot. So we need to try to solve for our y-intercept. And so now we're going to look back at this equation. Since we only have a slope and we don't have a y-intercept, can we find an x and can we find a y? Oops, I wanted to do that in a different color. And can we find a y? Well, if we look up, it says that our line passes through the point -2, 1. And we know that our coordinates are always written x, y. So I can look back up here and I can say our x is going to be -2 and our y is going to be 1. So I'll write those in here. We have an x value of -2 and a y value of 1. Now I can write this equation out using these values for x, y, and m, our slope. So y equals, well, instead of y we'll write 1 equals, now mx, m is going to be -3 because that's our slope, and x is just going to be in parentheses. We don't know, oh, I'm sorry, we do know x. X is -2. We're going to put that in parentheses because it's being multiplied by m, our slope. But what we don't know is the y-intercept, so we're just going to write plus b. So we have this one variable equation, y equals -3 times -2 plus b, to try to find our y-intercept. Well, now we're just going to solve this equation. So 1 equals -3 times -2 is +6 plus b. Now to get b by itself, we subtract 6 from both sides, and we get b is equal to -5. Well, now we have here a y-intercept. So with that y-intercept, -5, we now can write the equation of our line. We have a slope and we have a y-intercept. So our new line is going to be y equals -3 for our slope, leave x as it is. We're going to write -5 because our y-intercept is -5. Let's do another one. All right, let's try this one. Write an equation for a line that passes through the point 4, 6 and is parallel to the line 8x plus 2y equals 9. So again, we always know that we're trying to write this in the form, I don't like that color. We're always trying to write this in the form of y equals mx plus b. And we know that we need to find a slope and a y-intercept. Once we've done that, we have everything we need. If we don't have that, we'll need it. If we're missing one of those two, we'll need an x and a y. So let's start out by looking at our equation and seeing what we have. Write an equation for a line that passes through the point 4, 6. Well, 4, 6 is an x and a y coordinate. Let's just jot those down in case we need them. X is 4, y is 6, because this is written in x, y. And is parallel to the line 8x plus 2y equals 9. Well, we know that we're going to get a slope here, right? Our slope is going to come from a parallel line here. But you'll notice 8x plus 2y equals 9. We don't know the slope by looking at that because it's not written in slope-intercept form. So again, our first step is going to be taking this 8x plus 2y equals 9, and we're going to have to rewrite this in slope-intercept form. So remember, in slope-intercept form, you want to get y by itself. So I'm going to need to get rid of this 8x here. To do that, I'm going to subtract 8x. I have to do it to both sides, minus 8x. That cancels, and I'm left with 2y is equal to, remember, we always want to take this and plug it in right after the equal sign, so minus 8x x, and this is a positive 9, so I'll write plus 9. And now my last step is getting y completely by itself by dividing off 2 from every single term on both sides of the equation. Divide it there, and I'm left with y equals negative 8 divided by 2 is negative 4x. And then 9 divided by 2 is 4.5, or we can just leave it as plus 9 over 2. We don't care at all what the y-intercept of this equation is. Remember, all we're interested in is the slope, because this line is parallel to our line. So we can see that this line, 8x plus 2y equals 9, once we put it into slope-intercept form, has a slope of negative 4. So we'll put that up here. We have a slope of negative 4 for our line. And then we need to find a y-intercept, and we can't do that without plugging in for x and y. So now let's focus on our line. We're going to solve y equals mx plus b, and we're going to plug in for y a 6 equals, and for m we're going to plug in negative 4, and for x we're going to plug in positive 4, and then plus b we don't know yet, so we're just going to write plus b. Now we're going to solve this. 6 is equal to negative 4 times 4 is negative 16 plus b. Now to get b by itself, we need to add 16 to both sides. Get a little more space here. Plus 16 to both sides. That cancels out, and I'm left with b is equal to 6 plus 16, which is 22. So we can see here that b is equal to 22. So I'll go back up here and write 22 for our y-intercept. And now the last thing we need to do is we need to write our equation for this line. So in order to do that, we're going to write y equals mx plus b and plug in our slope and our y-intercept. So y equals m is negative 4, x plus b is 22, and there is our equation for this line. Let's do one last one here that's a little bit different. So in this problem, write an equation for a line that goes through the pair of points 1, 3 and 2, negative 4. Well, as usual, we know that we need to be able to write this in y equals mx plus b. We have to have a slope to do this, and we have to have a y-intercept. And if we have those, we have everything we need. We may also need an x and a y if we're missing either a slope or a y-intercept. As I look at this, it just gives me 2 points. It doesn't tell me a slope, and it doesn't tell me a y-intercept. But what I do remember is the slope formula. If you guys can think back to y1 minus y2 divided by x1 minus x2, right? We can use this slope formula to find the slope between any two coordinates. So I'm going to assign this 1, 3, and this 2, negative 4 with y's and x's. So we know that 1 is an x, and 3 is a y, and 2 is an x, and 4 is a y. And I'm going to make these my first set of points, x1, y1, and these are going to be x2, y2. So now I'm just going to plug into my slope formula, y1 minus y2. Well, y1 is 3, minus y2 is negative 4, divided by x1 is 1, minus x2, which is 2. I'm going to do the math here. 3 minus negative 4. Well, that's like, when you subtract the negative, it's like adding. So we're going to add 3 plus 4 is 7 over 1 minus 2 is negative 1. 7 divided by negative 1 is negative 7. So we can see that the slope between these 2 points is negative 7. Now, I need to find a y-intercept. And to do this, I need to be able to make a one-variable equation with b, and for that I need an x and a y. And I just so happen to have 2 sets of points that could give me an x or a y. I could either use 1, 3, or I could use 2, negative 4. I can't mix and match from them. Whichever coordinate I use, I have to use that x and y. So why don't we just pick this first set of x and y. X is 1, y is 3. Right, I took this set right here, and we're just going to make our one variable equation now. I have y is equal to mx plus b. Why don't, maybe I'll just jump right into y is 3 equals m is negative 7 times x, which is 1, plus b. Now we're going to do the math. 3 is equal to negative 7 times 1 is negative 7 plus b. To get b by itself, I need to add 7 to both sides. That cancels out. 3 plus 7 is 10, so 10 is equal to b. So I now have my b, which is 10, and now I need to write an equation for this line using my slope of negative 7 and my y-intercept of 10. So I'm going to write y equals negative 7x plus 10. And that's how I can write an equation of a line from just having two coordinates. All right, so I'm going to end the video there. And you're going to go on to some practice now. On your practice, you're going to be given various scenarios where you need to write an equation for the line, and you're always looking for the slope and the y-intercept and trying to pick that information out. And if you can't find the slope or the y-intercept, you may need to bring in an x or a y or use the slope formula to be able to get all of the information that you need to write the equation of the line in y equals mx plus b. As usual, if you have any questions, please reach out, or if you need any clarifications, and I will see you in the next video.